I'm Matthew Graff. I work here at Clovis Community College. I'm an instructor of automation, robotics, mechatronics. What we do here in the lab is teach students on industrial automation. So a few years ago, I got contacted from a professor at Texas A&M if I wanted to be involved in a National Science Foundation project. And the project was focusing on training technicians in the fourth industrial revolution. So when the grant was awarded, I let my computer science colleague know that there was a position that he could work on this grant with me. The reason I brought the computer science department in is I had no background in working with something like a Raspberry Pi. And so I needed that expertise. We brought in multiple student workers over time, and they assisted in getting ignition on the Raspberry Pi, getting the system working, stuff that a computer science student could do pretty easily, but it was just not the background that myself or students in the industrial automation program normally have.
My name is Bill Kearney. I am an instructor of computer science here at Clovis Community College. I've been working on this project for about 2 years now. My role here was as an advisor. I was here to supervise the student workers on the project, and so when they got stuck figuring out how to do something, then it was my job to unstick them.
We are training high school teachers and college instructors on the fourth industrial revolution system or Industry 4.0 project. And so what we do is we show the students how to initialize the system and then do some troubleshooting. I've been very impressed working with the educational and engagement program with inductive automation. Just from the get-go, I just got on the website and said, hey, I'm interested. And within a week, we were talking person to person going, hey, this is what we're trying to do, what we need to accomplish. From there, they were able to connect us with others in inductive automation to help with the project and give some feedback so that we would be doing stuff to industrial standards.
My name is Julian Laksamana. I'm currently a student researcher here at Clovis Community College working on the Industry 4.0 project. I work with the Raspberry Pis and Arduinos to collect data from smart home and display it on the Ignition webpage.
My name is Gurkaran Singh. I'm a student here at Clovis Community College studying industrial automation. I'm also a student employee. My main focus with the project is to establish MQTT connections between the edge devices and the Ignition SCADA.
We're focusing a lot on using what Walker Reynolds called a unified namespace, and we're using MQTT to move the data around. As we built out the system, we wanted something that literally for around $200 of hardware, someone could learn and experience how to use Ignition. It goes down to just a really simple smart home that they're programming and setting up and configuring a namespace for. The visualization is a big part, and so we're using perspective. One fun story was I was at a high school and I could see the teacher walking around telling students they're secretly pulling their cell phones out and kind of telling them to put away. I turned around and said, hey, here's the address, connect to this and you can connect into the system. And so then they had perspective running on their phone.
We're having the Raspberry Pi run Ignition on a terminal, and then the Arduinos connect to the MQTT broker through namespaces, and it sends the data through there, and you can connect through your phone or laptop and see the data from the Arduinos, which is really cool.
This is the Ignition webpage to control the smart home for this smart home here. So you can set the LED color here, and then set the yellow LED here. And then there's a little door on it.
Basically, we're using Ignition as a MQTT broker, using the MQTT distributor module as the broker, and then we're connecting all the edge devices, which are our smart homes, to the broker, and that's how we're getting the data into Ignition. Once we've got the tags in Ignition, I go ahead and create the UDTs, and thereon I build the perspective views. Once we've got the edge devices configured and publishing to the broker, we should be able to see the data come in on the MQTT engine on Ignition. So the namespace that we are using follows a simple structure. We've got a generic name, smart company, and then a neighborhood. So for each new neighborhood, we'll increment the number. And for each neighborhood, we've got object detection, we've got smart farms, and then we've got smart homes. Under each smart home are all the homes that are currently connected and publishing data, and these are all the tags that are being published. These tags are being used on here on this perspective view, displaying the data such as count, humidity, temperature, and there is some data coming in. The push buttons, got motion, and there's a touch. We could switch the homes from the smart home number. This drop-down auto updates each time a new home disconnects or connects. For troubleshooting the MQTT communications, I use MQTT Explorer connecting to the broker. It's really easy to see all the data come in and confirm that the homes that are actually connected, we are able to receive that data on the broker.
We also didn't want people to have the view that this is just like using cheap off-the-shelf toys and it has nothing related to industrial products. So what we did is we looked out and tried to find a product that would be similar, that's being used in industry. We located Opto22. They have a single board Linux system, and we've used that for our college level systems. So we are giving institutions through our grant those Opto22s, and they're able to experience both working with cheap system that they could easily buy for a whole classroom, every student, and using an industrial system with Opto22. Having student workers has been helpful because I could see how much they could take on and also discuss with them, well, how would we teach other students? Bouncing ideas off of them and trying to create a student-centered approach to teaching. Julian brought a video in from object detection that's run on another application.
We currently use YOLO V8 to collect data from ESP32 cameras and then process it through the Raspberry Pi, and then that displays it on a web page, which Ignition gets the data from and it displays it on there.
Working on this project has really exceeded my expectations. Been super impressed with students working at different levels. They generally have brought the project further along than I was able to do just on my own.
Working on this project exposed me to Ignition and Opto22 and MQTT. I found this local company focused on agricultural monitoring and automation. Their main product was based on Ignition. They were using Opto22s for their controls and MQTT to transmit all the data. I reached out and expressed my interest, and next morning I hear back from the president of the company, and my skills aligned with their products, which led me to be able to get a job over there.
My name is John Williamson. I am the president of Farm Data Systems. We have about 20 years experience working with farmers to help them improve irrigation management. We've been working with Opto for about 8 years now, using their controllers. For Ignition, we've been working with them for about 6 years now, so we've probably done a couple hundred projects already with Ignition. So one of our biggest challenges is building a team of technicians who have capabilities around ignition and low voltage electrical systems. But one day, Gerkron contacted us directly, which was really good. We had internships available at the time, but Gerkron expressed an interest in a full-time position. So I talked to him over the phone, and it was very clear his career objectives were very much in line with what we were doing. So we met in person, and I already knew he could add value on day one. His training at college was really so well suited to the work we're doing here. Can't speak highly enough about the program and how well suited it is to our business.
My day-to-day over at Farm Data System includes configuring Opto22 products for upcoming projects, monitoring alarms for the products that are already out in the field, trying to troubleshoot any networking issues that we face, and trying to help customers solve those problems. I feel that the skills that I learned working with Industry 4.0 projects were highly relevant and were really beneficial for me in being able to be successful in my current role.
We've had software engineers work on this project. The first one, Nero Cabrero, worked on this for about a year, and then he transferred to UCLA. And then he just recently messaged me and told me that he got a job in a related industry. So an absolute success story.
Working with Ignition and all the software we have now provides a good foundation for me to build other projects in the future.
Learning all these concepts using hardware as well as software helped me improve my troubleshooting skills. While using hardware, you have an opportunity to make more mistakes. It may be a wiring issue, or it could be a software issue, such as setting an incorrect IP address. It helps you gain a deeper understanding of the whole system, trying to troubleshoot the issues and fixing the problem.
Projects really get students excited. And so when we use Ignition, we see students, rather than trying to race to the door, and leave 5 minutes early, they stay around for maybe an hour or two extra, trying to get their project working.
One of the things I work on with my students a lot is trying to get them to go out into the real world and interface with the real world. Getting them to actually, turn a motor on, or to turn a light on, or to open a door and things like that is oftentimes just a mind-blowing experience for them.
Very cool for students to see their knowledge have a physical effect on the real world.
I encourage anyone who wants to look at this project, go to our GitHub page. This was funded by the National Science Foundation, and I just feel like we are obligated and we want to share everything we have here. There's nothing we're hiding, so feel free to use that. You can take this and use it in a classroom, or if you're an engineer and you just want to poke around, or just someone that wants to have a fun automation project, you can just get a little $55 home from Amazon and pay $100 for a Raspberry Pi, and you'll be set to go.